Okay, in this tutorial we will learn how quicksort works. In quicksort we will take any element as a pivot element, and then we will move all the elements which are smaller than pivot element to the left side and all the elements which are greater than pivot element to the right side. And let's see with an example. And here I am taking first element as a pivot element. We can take any element as a pivot element, but in this example I am taking first element as a pivot element. And what I do here is, first I will check what are elements smaller than this pivot element, and 1 is smaller than pivot element, so I will move 1 here, and 5 is smaller than 6, so I will move 5 here, and 22 is greater than pivot element, I will just ignore it, and we are already done with 5, and 22 is greater than 6, so I will ignore it, and 4 is smaller than 6, so I will move 4 here. I am done with 4, and 10 is greater than 6, I will ignore it. 7 is greater than 6, I will ignore it. So here we are done with all the numbers which are smaller than pivot element, so I can safely put pivot element here, and whatever elements are remaining I can keep it right side. 22 and 10 and 7. If we notice here, we have moved 6 to its right position, and if we see all the elements which are left side 6 are smaller, and all the elements which are right side 6 are greater. So in this way we can now we need to repeat this process again. Now we are done with 6, and it has given two arrays, left side array and right side array, and I will repeat this process again for both the left and right side. Here I am taking 1 as a pivot element. Now we will check elements which are less than 1, because that is our current pivot element. Here I rounded 6 because we are already done with 6 here, and if you see 5 is greater than 1 and 4 is greater than 1, so in this array from here to here we don't find anything which is smaller than 1, so I can keep safely 1 here, and then whatever remaining elements are anyhow greater than 1, and I am doing the same. And now we are done with 1 because we have moved it to its right position, and now it has given this array. Now we will do the same process. Now we will apply quicksort, and we will apply quicksort on this array from here to here, and I am taking 5 as a pivot element, and I will check what are elements which are smaller than 5. 4 is smaller than 5, so first I will add to this array 4, and then I will check in this array what are all elements smaller than 5. So only 4 is the smaller than 5, so I am done with it, so I can safely keep 5 here. So this is the right position for 5, and we are done with 5. And because 4 is only single element, we don't need to do anything, and I am keeping 4, I am marking 4 is also as done. And now we will move to right array, and we apply quicksort to this array from here to here. Okay, now I will take 22 as a pivot element, and I will check what are all elements smaller than 22. 7 is smaller than 22, so I will add 7 here, and 10 is smaller than 22, I will add 10 here. So I did not find any smaller element than 22, so I will add 22 here. So now we found right position for 22. We are left with only this part, and we will apply quicksort again for that array. I will take 7 as a pivot element and I will apply quick sort. So I will find out if there are any smaller elements than 7. I did not find any smaller element because only 10 is left. 10 is greater than 7. So I will add 7 here, and then whatever elements which are greater than 7 I can keep it right side, that is 10, and I am done with 7 because we have only one element. We don't need to do anything. That is the right position for 10 also. So this is how quick sort works. And if we see, all the elements are already sorted, and I will just explain the procedure once again. Here we have taken first element as a pivot element, and we try to move all the elements which are smaller than 6 to the left side, and all the elements which are greater than 6 to the right side. How we have done? Once I took first element as a pivot element, and I tried to check what are all elements smaller than 6. So I have added first to the I have added them to the array first. So here 1 is smaller than 6, I have added 1, and 5 is smaller than 6, I have added 5, and 22 is greater than 6, I ignored it, and 4 is smaller than 6, I added it, and next I moved to 10. 10 is greater than 6, I ignored it, and 7 is greater than 6, I ignored it. And once we are done with all the elements which are smaller than pivot element, we can add pivot element there, because we are already done with all the smaller elements, and the pivot element is supposed to come in that index, and leftover elements will be greater than pivot element. That's why I kept it here to the right side. And when we are taking this order, doesn't matter, it can be any order. The only real rule we need to follow is the smaller elements should be left side and greater elements to be right side. And we repeat this process again. Next time we will apply the same procedure to this array, and once we are done with this array, and we will start with this array. That is what I have done here, and I hope you understood this algorithm. And then we will see what is the time complexity for this algorithm. Okay, now we will see time complexity of a quick sort. So when we take first element as a pivot element, to find out its right position in the array, we are processing n-1 elements. That is n-1 comparisons we need to do for the first element. Then it divides array into two half parts. Assume that this pivot element moved to exactly mid position of the array, so that it divides array into two half parts. And to move second position to its right position, to move second element to its right position, it needs n-1 by 2 comparisons, because now array is divided into half part. And to move third element to its right position, we need n-1 by 2 by 2. It is n-1 by 4. And like this, at some point it will become 1, and instead of n-1, for simplicity I am taking it as n. So the time complexity will be like this. For first element we need to do n comparisons, and for second element we need to do n by 2 comparisons, and for third element we need to do n by 4 comparisons, and it will be at some point 1 comparison. So if we take n as a common, it will be like 1 plus 1 by 2 plus 1 by 4 plus, and so on, 1 by n. And this is nothing but log n base 2. So this is the best case time complexity, assuming that each pivot element divides array into two exact half parts. Let's take another example and see. I have taken another example, and this array is already sorted. I am taking first element as a pivot element, and I will check what is the right position for that pivot element, and we will compare with all the elements, and finally we will find that that is the right position for that pivot element, because array is already sorted. And it is not dividing array into two parts, because the left side it is 0 and right side it is n minus 1. And again we pick the second element, and then we will look for its right position. But right position is that only, because it is already sorted. That requires n minus 2 comparison. So like this, we need n minus 1 plus n minus 2 plus, we need n minus 1 and n minus 2, and for third element we need n minus 3 comparisons, and finally it will be 1. So, and if we write, we can also write it in this way: 1 plus 2 plus and so on, n minus 1, because I am writing from right side to left side. This will be, so this is nothing but sum of n minus 1 numbers, that is n into n minus 1 by 2. This is nothing but order of n square time complexity. So this is worst case time complexity. See implementation logic of quicksort. This is the input array, and I have taken first element as a pivot element, and I have taken a left pointer. I need to identify an element which needs to be moved to the right side. Let's start with first element, and here 1 is less than 6. I don't need to move it to the right side. I will increment my left pointer, and now left pointer is 5. 5 is less than 6, and so I don't need to do anything, and I will increment my pointer, left pointer, and now 22 is greater than 6. So 22 needs to be moved to the right side, but I don't know exactly where to move 22. We need to identify a smaller element than pivot element from the right side, and then I can swap 22 with that element. For that I will take right pointer also. So once I found greater element than pivot element, then I will stop there, and then I start from right side. 7 is greater than 6, so I cannot swap with 7, so decrementing right pointer. And 10 is greater than 6, we can't swap, and I am decrementing right pointer. And 4 is smaller than 6, so this is the right element to swap with 22. So I am swapping these two, 4 and 22. Here 4 should come, and here 22 should come. After swapping, I can decrement right pointer, and I can increment left pointer. This process we need to do until left is greater than, less than or equal to right. But here left is already greater than r. So we will stop now, and after we complete this process, whatever index of the right pointer, whatever value is there in that index, that we will swap it with the pivot element. Pivot element is 6, and our the value which is at right index is 4. We will swap these two. Four and 6, and this is how we will implement quicksort. Okay, now we will see how to implement quicksort. Here I have taken input array which needs to be sorted, and I have taken a partition method which takes input array, and it takes first element as a pivot element, and it tries to identify what is the right position for that pivot element. And here left index and right index tells in input array what is the starting index and what is the last index. That's what it tells. Initially starting index will be 0, and left index will be 0, and the right index will be the last index of the array. And let's take first element as a pivot element. I am taking int pivot is equal to input of, and here instead of taking input of 0 we need to take L, because that's what it tells what is the starting position for this input. And I have taken first element as pivot element. Then we need to check what are all elements which are smaller than this pivot element. So how do we do that? We start with uh, next index, that is 1, and anyhow right index will be the last index of the array as of now. And from here we need to identify all the elements which are smaller than pivot element, and once if we find any greater element than pivot element, that needs to be swapped with smaller element from the right side. So let's do that. Once we take the pivot element, we will also take pivot index. I I will tell how it is useful later, but let's take now pivot index, that is L only, because initially L starts from 0, but once we take pivot element then L should move here, and that's what I am doing. Now I am incrementing L plus plus, and we need to identify what we will go through element one by one. If it is smaller we ignore that, and if it is greater then we will try to identify from the right side what is the lesser value than pivot element, so that those two can be swapped. So this process should happen until left is less than or equal to R. That's what I am doing it here. While left index is less than or equal to right. Now if the value which is at left index is greater than, if the value which is at left index, if it is smaller than pivot element, we don't need to do anything. If it is a greater than, then only we need to swap it with the element which is at the right side. So what I am doing here is input of L, if it is greater than pivot, not pivot index, pivot, then only now we found an element which is greater than pivot element. So what I do here is from right side I will check what is the lesser value than pivot, so that I can swap those two. So that also should happen until left is less than or equal to right. So that is also a loop, because first initially we start from here and we will check whether it is less than pivot element. It is not less than, then we decrement R, and again we check 10, whether 10 is less than or equal to 6, that is not less than, so we will move to here. Finally we will find 4, that is a less than pivot element. Then we will swap this 22 with 4. That's what we have seen previously, right? So once we find this, we will swap 4 with 22. And here I am taking while left is less than or equal to right, and I will start from, I will again compare if input of I, sorry, input of R, it means right side index, and is less than or equal to pivot, then we need to swap, we need to swap, we pass the swap function takes input array and the indexes which we need to swap. Here we are going to swap left index and right index. That's why I have taken like this. Let's write the swap function. It's very simple. Public, I'm just writing a method name swap, and then input int left, int right. This is a int array, integer array. Right, we need to swap these two. Initially I am assigning value which is at left index to temp, and then I will assign value which is at right side to left index, and then finally I will put input of r is equal to temp. So basically it swaps the element which is at left pointer with the value which is at right pointer. Okay, once we have swapped 4 and 22, this should decrement, the right pointer should decrement. Now I will do that. I have done that, and once we have swapped left pointer should increment. That's what I am doing here. Okay, once this process is done, whatever value which is at right index, we need to swap that with pivot element. So let's do that. Swap input, we need to swap it with pivot index comma right. It needs to be swapped with right pointer. Whatever value which is at right pointer, with that it needs to be swapped. So here initially we have taken pivot index for this reason. Now we can swap. Once we swap, we can simply return r. So this is the right index for the pivot element. Now we have written the partition function. Let us see how quicksort we will write the quicksort function. That is public. It should return integer array which is sorted, and then quicksort. It takes input, that is an array, and left index and right index. So now we will call the partition method. We will get the right position for the first pivot element, and then we divide array into two parts, and again we apply quicksort on left array, and then we apply quicksort on right array. And let's do that. Int pivot index is equal to partition. We are passing array, and we are passing what is the left pointer and what is the right pointer. It gives right position for the pivot index, pivot element. And then once we get the pivot element here, we can divide array into two parts, that is left array and right array. Once we get the pivot index, how we are dividing array into two parts? Left array we can get it by doing pivot index minus 1, that's what this one. Right array we get it by doing pivot index plus 1. In this case, if this is left and if this is right, while taking left array we don't change left index, only right index will be changed. While taking a right array, only left index will be changed, right index will not be changed. So first I am taking left array, that is I am calling quicksort, and I am passing input, and left will not change, and right index will be pivot index -1. And how do we get the right array here is, I will do pivot index +1, that will be left index, the right index will be as it is. So I am just writing the right index first, and left index will be pivot index +1. And now we are calling quicksort recursively, and this should happen until left index is less than r. If left index is less than right index, then only the quicksort should call happen recursively, otherwise it should return input. Now our quicksort function is ready. Let's call that quicksort and see whether it's giving correct result or not. I'm just removing this and I will rewrite again quicksort input. This is the input array, and initially left index will be 0 and right index will be last index of the array, that is input dot length -1. Here I am writing length -1 because our starting index is 0, and it returns sorted array, that I am storing it in output, and then let's print it. Now I am printing all the elements in the output array, and see, let's see whether it's printing sorted elements or not. Here you can see the elements are in sorted order 1, 4, 5, 6, 7, 10 and 22. I am giving this link below video description. Please check it out, and thank you.